Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. And today we are going to complete the Regents exam for January 2019 for Algebra 1. I think this would be the last one I'm going to work for you. So we start with part 3. The first problem says Marilyn collects old dolls. She purchases a doll for $450. Okay, so it says research shows that this doll's value will increase by 2.5% each year. Write an equation to determine the value V of the doll T years after purchase. So basically, the value V would be the present price, which is P, times 1 plus the interest rate, the annual interest rate, raised to the power of the number of years. Okay, so if I want to write it using the values given, I would say it's a 450. I is 2.5%, meaning 0.025, so 1.025 raised to the power t. That's it. Then in the second part, it says, assuming the doll's rate of appreciation remains the same. Appreciation meaning increase in value, depreciation meaning less. So it increases 2.5%. It will continue to do that every year, assuming. So will the doll's value be doubled in 20 years? Well, for your own knowledge, this has nothing to do with the course. You are not going to use it in the test. But from just pure math, when you do like economics, they have two things called the rule of 72. The rule of 72 only tells you if you want to know roughly how long it's going to take for a value to double, like a price to double, divide 72 by the interest rate, which is 2.5. 2.5 like 5/2. So if you divide 450, it's like you are multiplying 450 I'm sorry, 450 divided by 2.5, it will give you 72. What am I saying? 72 divided by 2.5%, and sure enough, it's like multiplying by 4. So 7.2 would give you 28 years, 0.8, roughly 29 years. So definitely it won't double. But to show it, you have to say, okay, let me substitute and see in 20 years, what would be the value in 20 years? It would be 450 times 1.025 raised to the 20th power, and that should definitely would be less than 900, which is the double. How do I know? Because that should be like roughly 28.8 or 29. So I'm going to say 450 times 1.025 raised to the 20th power, and I get $737.38. So I would say no, it won't double. And justify your answer. After 20 years, the doll's value will be less than double its price, current price. Two times 450 equals $900. And this number is less than $900. And since I mentioned the law of 72, there is another law that tells you the money will triple. If you want to know how long the money will triple, you will divide 120 by the interest rate. So you will get 48 years. Okay, so 72 for double, 120 for triple. This is for your own knowledge. So if you want to, somehow you need that information, you can do it in your head quickly, or with a calculator, you don't need much work. The second problem, I think I think I'm doing the zooming too much, so you don't see the whole page. Let me decrease it a little bit. Yeah, maybe that's good enough. So the second problem says the data given in the table below shows some of the results of a study comparing the height of a certain breed of dog based upon its mass. So height as a function of mass. Write the linear regression equation for these data. We have a calculator where x is the mass and y is the height. Okay. And round all values to the nearest tenth. So I'm going to go to stat, edit. I will enter the mass here as x 4.5, 5, 4, 3.5, 5.5, 5, 5, 4, 4, 6, 3.5, 5.5. Make sure that you enter them correctly. Then 41, 40, 35, 38, 43, 44, 37, 39, 42, 44, 31, and 30. So now we enter the values, the 12 values. I'm going to get out and go back to this, or go to the stat and go to calc, and number 4 is linear regression. It will give it to you as ax plus b. So I get y equals a to the nearest tenth would be tenth or 100? Tenth. 1.9x plus 29.8. That's it. State the value of the correlation coefficient and explain what it indicates. So R, it's given to you here to the nearest tenth, it would be 0.3. Explain what it indicates. It indicates a 0.3 would be a low, really low positive correlation between x and y, or between height and mass of this breed of dog. Just trying to write quickly, don't want to waste your time. Notice that last time I think the R didn't show up because I had the diagnostics off. So all what you have to do, if you don't see the R, you have two ways. The first one is to say second catalog and go down until you see diagnostics. So select diagnostics on, click the enter button twice, and now it will show. If you don't want to do that, then the other way is to go to tests and select the one that has linear regression t-test, which is the F. And then you already have the X in the L1 and the Y in L2. So you go to calculate, and you can see here you have the A, you have the B, and at the bottom you have R squared and R. Okay. So whichever. I think you do the diagnostics on once and for all. Miranda received a movie gift card for $100 to her local theater. Matinee tickets cost $7.50 each, and evening tickets cost $12.50 each. If X represents the number of matinee tickets and she could purchase, and Y represents the number of evening tickets, write an inequality that represents all the possible ways Miranda could spend her gift card on movies at the theater. So if you buy X tickets and each one costs $7.50 for matinee, then all of them will cost $7.50 times X, where X is the number. If it's X is 1, you pay $7.50. If it's 2, you pay 15, and so on and so forth. Same thing for Y. Y is the number of evening tickets, and each one costs $12.50. So $12.50 times the number of evening tickets will give you the total cost. Okay, you are going to spend her gift card, so she's not going to pay from her own pocket, so that cannot exceed $100. This is the equation. And then they tell you on the set of axes below, graph this inequality. I said equation by error. Of course, it's inequality. So let's number these. So 1, 2, 4, 6, 8, 10, 12, 14, 2, 4, 6, 8, 10, 12, 14. I can write this equation in terms like most people would like that. I don't care. I could have done it differently, but as you know, I think I mentioned that before. But let's say, first of all, I want to move this to the other side. So I'm going to subtract 7.5x. And then I'm going to divide both sides by 12.5. So I will get y is less than or equal. When I divide negative 7.5 over, this is 2.5 times 3, and this is 2.5 times 5. So it's negative 3/5 x. And then 8 times that is 100, so plus 8. The y-intercept is 8. So I have a point here. And then the slope is negative 3/5, meaning it's going down. Every time I move to the right, I go down. If I move to the left, I go up. So I'm going to, every time I move 5 units, I am here. So if I move 5, 1, 2, 3, 4, 5, I have to go down 3, negative 3, 1, 2, 3. So that's a point. 1, 2, 3, 4, 5, 1, 2, 3. And now I'm going to connect the dots to draw the inequality line. It's solid because it's less than or equal, not less than. If it's exactly $100, yeah, you can do it. So the equality is part of it. And here is my solution set, or the feasible region, as we call it in operations research. It means the same thing. And that's basically that. So that's the second part. The third part says that what is the maximum number of matinee tickets, meaning the maximum X you can get with the gift card. Of course, this is 13, this is 14. You cannot buy half a ticket, so the maximum, so what maximum equals 13 tickets, matinee tickets. Explain your answer. The x-intercept is between 13 and 14, which means she can't buy more than 13 tickets with her card. Gift card. Okay, pretty straightforward. So it's 3 parts question. You go, this would be the third or the fourth. Oh yeah, no, that's the last, the fourth. I thought it was the third. Okay. One spring day, Elroy noted that the time of day and the temperature in degrees Fahrenheit. His findings are stated below. At 6 a.m., the temperature was 50. For the next 4 hours, it increases or rose 3 degrees per hour. The next 6, 2 degrees per hour. Temperature stayed steady till 6 p.m. And then for the next 2, drop by 1. The temperature then drops steadily until that at midnight. On the set of axes below, graph Elroy's data. Okay. So let's mark, maybe I'll use a color so you can see. If I use this pencil, I don't think it would be clear. So at 6 a.m., the temperature was 50. Here is 6 and here is 50. These increases by 1 hour each because that's 6. but these are only 5, so it goes up 2 degrees, so 52, 54, and so on. So be careful, the scale is not the same. So we start at 50. For the next 4 hours, so from 6 to 10, here is 10. The temperature rose 3 degrees per hour. Notice this is odd, even numbers, so 3 would be in the middle. So we can say every 2 hours, it's easier to say 6 per 2 hours, right? So it would be 56 at 8 o'clock. And then it would be 62 at 10 o'clock, and that's it. So it rose 3 degrees every 2 hours. So now I'm going to join these 3 points. That's the first part they told me. The slope is 3. Then the next 6 hours meaning from 10 to 16, which is 4 p.m., it increases 2 degrees per hour. So notice that every square here is 2 degrees and every square here is 1 hour. So I will go that for 6 hours until I go to 4 p.m. Okay, it's like that. Here is 4 p.m. So I will go to this point. This is the second part. So I did this, I did this, I did that. Now the temperature then stayed steadily until 6 p.m. 6 is here. Oops, I'm sorry, I didn't go to, oh, I didn't go to 4 p.m. I stopped at 3. I'm sorry, I wasn't looking carefully here. Yeah, this is 4. So in fact, you will reach what? 74. And then you stayed constant till 6 p.m. 6 p.m. is here. So for the next 2 hours, it stayed constant. Then for the next 2 hours, like 8 p.m., it dropped 1 degree per hour. Notice for the next 2 hours. So this is 2 and this is 1. So for the next 2 hours, it drops 1 per hour, 1 degree Celsius per hour. So it will, after 2 hours, it will drop 2 degrees from 74 to 72. So after 2 hours, it will come here. Just follow what they said. Be careful with the scale, because as I said, the X scale is every square is 1 hour. Vertically, every square is 2 degrees Celsius. And finally, the temperature at midnight drops to 56. Here is 56 again, and here is midnight. So it drops to this point. That's probably, it will take time, but if you draw it correctly, the rest should be easy. Okay, state the entire time interval in which the temperature was increasing. They tell you it rose for 4 hours and then for 6 hours. So really from 6 a.m., the temperature was increasing from 6 o'clock a.m. to this point, and then it stabilized, and then it starts to drop till 4 p.m. 4 p.m. That's it. That's an easy question. The second question, determine the average rate of change, average, meaning change in y over change in x, assuming it's a straight line. So we say if in degrees per hour from 6 to midnight. So if that's what we are saying, we are saying that if the drop from 6 p.m. from this point to that point was straight, steadily, meaning if I draw a straight line, I'm not gonna, you don't draw it in the test. I'm just telling you what it would happen, what happens. if you are drawing a line like that, what would be its slope? That's basically the question. You have to understand change or average rate. Average here meaning straight line. Change, rate of change is the change in y over change of x, but that's the definition of a slope. So if you can find the slope by saying, okay, I was at this point and then I became at that point, this point at 8 o'clock, it was 68. So I dropped 6 degrees in 2 hours, meaning I dropped 3 degrees every hour. I solved the problem. But to write it mathematically, I'm going to say it's so average rate of change in the equals temperature at midnight minus temperature at 6 p.m. divided by the total number of hours from midnight, which is 12 minus 6. That's a distance of 6, right? That's the definition of a slope. The temperature at midnight, they told me it's 56, right? They already give me that. So I say 56 minus. The temperature at 6 p.m., they didn't give that to me, but if I drew it correctly, I would get 74. Over 12 minus 6 is 6. This is negative 18 over 6. It's negative 3 degrees Celsius per hour. You have to write the units, be careful. Meaning it's dropping because negative 3 degrees Celsius every hour. Yes, you see the slope going from 6 to 8. I dropped from 74 to 68, which is 6. 6 in 2 hours is 3 per hour. Common sense. So that's part 3. If we want to complete that, we'll go to part 4, the last problem, which usually is multiple requirements, but the previous one was also multiple requirements. This is like 6 credits. It says a recreation center ordered a total of 16 tricycles and bicycles. So we don't know how many of each. From a sporting goods store, the number of wheels for all the tricycles and bicycles total 38. Write a linear system of equation where T represent the number of tricycles, B represent the number of bicycles. Whether it's bicycles and tricycles, or chicken and cows, or pennies and dimes, it's the same problem. First of all, they give you, notice, as I said it before, and I keep saying it until you get bored of me. When I say T, I've seen many students in the test. Luckily, they give you the definition. But in tests and homework in schools, I see students write, let T represent tricycles and B represent bicycles. What do you mean? So the T, when I see a T, I will see a tricycle? No, it's the number of bicycles and number of tricycles. Okay, so I have 2 things. The number of tricycles, which is T, plus the number of bicycles, which is B. Oh, they use lowercase. Okay. Equals 15 because they bought 15 tricycles and bicycles. But when it comes to the number of wheels, you say, okay, if I have 1 tricycle, tri means 3. It has 3 wheels. So 2 will have 6. How did I get the 6? I multiply the number of tricycles by 3. But the number of tricycles here is not a number. It's a letter. It's T. So 3T. 3T is the number of wheels in T tricycles. And the number of wheels in B bicycles is 2B. Bicycle. B, bi is 2, right? And that equals 38. How easy is that? These are the equations. They didn't ask you to solve them. It's easy to solve, but they told you on the set of axes below, graph this system of equations. So I'm going to draw the first equation in blue, okay? So I have t plus b is 15. This is t, this is b. So here you can see the slope is -1. Why? Because if b is the y, I can write it as b equals -t plus 15. The y-intercept is 15, and I drop 1, a slope of -1, meaning every time you go, you move 1 to the right, you go 1 down. Okay, so I have to go from 15 to 15, definitely, if I'm going to go 1 to 1 to 1. That makes sense, right? So this is the first equation. And I can write in blue t plus b, or b equals -t plus 15. And then in red, I'm going to draw the second one. First of all, I'm going to subtract 3t from both sides. And then I'm going to divide by 2. So I get b equals -3/2 t plus 19. If you divide the right-hand side by 2, I don't have a space, so I didn't do it, but it's better to write it so you don't get it wrong. B, I had to write this in red. -3/2 t plus 19. 19 is here, okay? And the slope is -3/2, meaning every time I move 2 to the right, I go down 3. 2 to the right, down 3. And this would be the second equation. This is b equals -3/2 t plus 19. Okay, what is the next question? Based on your graph of this scenario, could the recreation center had ordered 10 tricycles? Explain your reasoning. Can t be 10? Can t be 10? Notice, they got 15. So really the only possible or the correct answer is 8 tricycles and 7 bicycles. 8 tricycles is 24 wheels. 7 is 14. So when you add them, you get the 38. So this is the answer, which is 8 and 7. So could they buy 10? No, they couldn't. Because if they bought 10, they will get 4 bicycles, so they add up to 14, not 15. So it satisfies this equation. Yeah, that would be 38. Like 10 times 3 is 30, and 4 times 2 is 8. So they add up to 38. But they would have bought 14, not 15 tricycles and bicycles. This is the only solution that satisfies both equations or both constraints. So no, because if they had bought 10 tricycles, they couldn't have bought, for example, 5 bicycles, because that would give 40 wheels. 10 times 3 and 5 times 2, for example. Or you can say no, because if they both 10 tricycles and 4 bicycles, so that the number of wheels would be correct. 10 times 3 is 30 and 4 times 2 is 8. So then they would have bought only 14 tricycles and bicycles. Or you could say, so you can say this, or easier, you say, or according to my graph, they had both 8 tricycles, not 10, and 7 bicycles. So in order to satisfy both equations, you had to be here. Okay, and that basically concludes the test. And again, 2 things. If you have any questions or comments, please let me know by sending me a note. Or if you don't have anything, then again, I wish you all the best. I hope to see you soon in the future. And I wish you all the best in your test. Thank you very much. Have a great day.